Hey everyone, welcome back. In this video, we are going to continue working on points of intersection. Now, we did an example in the last video, and in this one, we're going to do, I believe, two examples. Since this does sometimes take a little bit more work, um, like per problem, we'll see how long it takes to get through one. But since the process is not overly different from some of the stuff that we've done before, hopefully it won't cause us too many problems in this lesson. So what we're going to do is we are going to begin by graphing two lines, and then we will, and I'll give the equations as well, but first we'll draw the plot. We'll try and sort of estimate where the point of intersection might be, and then we'll go from there and figure it out mathematically. So let's call this point of intersection examples. Point of intersection examples. Brilliant. All right. So, yes. So let's we'll do two examples. So we'll number them with Roman numerals. So let's start by putting a little 1 right there. So what I'll do is I'll give you two equations, and we will draw the graphs, and then we will calculate the point of intersection of those two lines. So the first line will obey the equation y equals 1/3 times x, so 1/3 x minus 1. Okay, so we'll, in a second, we'll work on figuring out the slope and intercept of this line and of the second line. And the second line is much simpler. It's just y equals x, which is the easiest line that we could probably hope to draw. Or at least one of the easiest lines. So let's draw in our Cartesian plane. Got our axes looking something like that. And we will begin by plotting these two lines. But of course, when we're trying to estimate what the point of intersection is, we can't really be sure if it's a graph that we've sort of hand-drawn, because if our graph isn't perfect when we're, divvying up the axes, when we're putting in these tick marks, if this isn't perfect, then the graph might look a little bit misleading later on. So we try to keep it as, as consistent and accurate as we can, but it's not necessarily as consistent as we need it to be to get our answer directly from the graph. So what we'll do is, let's first off number these. Then we'll graph them, and then we'll try and estimate the point of intersection by looking at the graph, but then we'll actually calculate it mathematically. And so what you'll notice is that what we're doing right now with drawing the graph of it, that's just to give you an idea of where roughly you should expect your answer to be. You don't actually have to draw a graph in order to find the point of intersection. The actual method that you'll use to find the point of intersection is purely mathematical. So it really, the method that we use goes right back to our previous unit when we were working with word problems involving a couple of different variables, and we would have two equations that involved x's and y's, and then we had to find a value for x and a value for y that satisfied both of those equations. And that's basically what we're doing here. The only thing is now we have the context of a graph, and we're trying to figure out where those two lines cross each other. So all that we're doing is we still have two equations, still with x's and y's, and all we're doing is we're trying to get a visual description of these two equations, which is why we graph them. And then once we have that visual idea, we can sort of guess where the point of intersection actually is, and then from that we calculate mathematically and check our answer to see if it makes some sort of sense. So like for example, if you graph two lines and it looks like they're supposed to intersect at the origin or very, very close to the origin, and then you're getting an x value of 10 and a y value of 35, chances are you did something wrong because your graph is telling you that they should be intersecting at the origin. That's provided that you've drawn your graph correctly, of course. Yeah, so assuming you've drawn your graph correctly, you should be able to use it as a guideline to check roughly how accurate your actual final answer is. So, if I start by sketching out the simpler of the two equations, so that's this equation 2 here, y equals x, that's just a straight line that passes through the origin. Well, I mean, they're all straight lines. So that's a perfectly, at a 45-degree angle at that nice diagonal, is going to pass through the origin and just continue in that bottom left to top right kind of curve. I'm going to put in those little dotted lines just because it helps me out when I'm trying to plot some points. I'll do that as well before I actually graph the line. Are those reasonably straight? Straight enough for what we're doing, I think. Oops. Definitely not the straightest lines, but again, hopefully it'll serve its purpose as a little bit of a guideline for us. Yeah, it looks decent enough to me. And one more down here. All right, brilliant. So now we can use that to help us plot our points. So we get another one up over there, another one down over here. And if you're still confused about how I'm getting these points, basically, whatever the x value is, your y value is going to be the same thing. So over here, my x value is 1, and my y value is also 1. My x value is 2, my y value is also 2. So it's going to be on this perfect diagonal line. Down here, my x value is negative 2, my y value is negative 2. So that's why we've got a point over here. And so then we can just go ahead and connect those, and we get something that looks like this. And we'll just extend that out to the other edge. And there we go. That's our line y equals x, graphed out and ready to use. Now let's plot the other one. So for equation 1, if we're looking at this one, we need to find the slope and we need to find the y-intercept before we can do anything else. So let's remind ourselves that the equation of a line is y equals mx plus b, where the slope is m and the y-intercept is b. So if we just compare this equation for like the general form for the equation of a line with equation 1, we'll see that our slope is this 1/3 because it's the thing that's attached to the x. So this is telling us that our slope is 1/3. And our y-intercept is going to be this plus b on the end. So whatever is after the x is in your y-intercept. So that means this minus 1 is our y-intercept. And remember, you have to remember to carry that minus sign because the minus sign doesn't show up in this original equation. So the intercept isn't at 1, it's at -1. So we have to be careful of that. But that's it. Now that we've got that, we can use this to graph the second line. Let's just remind ourselves ever so quickly that slope is also equal to rise over run, which we'll come back to in just a second, because the first thing we do is we take our y-intercept and we plot a point at that value on the y-axis. So our y value on the this value on the y-axis, -1, is going to be down here. So we put a point right there. And then from there, we go, so we've got a rise of 1 and a run of 3. So that means we go up 1 and then over to the right 3 units. So from here I go up 1, that brings me here, right back to the origin, and then I go over 3 units, so it takes me right over there. Perfect. Now, I can't plot another point in that direction, but what I'm going to do is I'm going to plot a point going in this direction, like I'm going to continue that line towards the left instead of plotting my points towards the right. And to do that, basically, if I treat my run as, or sorry, if I treat my rise over run as, let me get rid of something so I can sort of sketch out what I'm trying to say. Let me get rid of this. And let me get rid of the y-intercept, actually, because we know what that is and we've done our work with it. So if I've got a point here, and I've got some rise, and I go up, and some run, and I go over to another point right there, if I do the same maneuvers, if I still have a rise and a run, but I do both of them in the opposite direction, so instead of doing my rise going up, I send my rise going down, so basically like a negative rise, and then my run, instead of going to the right, I go to the left, so basically a negative run, then I get a point over here, which you can see these three, as long as I've drawn it reasonably correctly, these three still line up quite nicely. So you can either do your rise over run as going up and to the right, where this would be your positive rise and your positive run, or you can do it as going down and to the left, where down is technically a negative rise and left is technically a negative run. So basically what we have here is our rise over run was supposed to be 1/3, but if I wanted to go down and to the left, then going down means I've got a negative rise, and going left means I have a negative run, and those negatives cancel out. So the slope of that line is still going to be positive 1/3, but I've just stuck 2 negative signs in there to plot a point going in the opposite direction. Alright, hopefully that makes sense. So what we're going to do now is we'll return to that y-intercept. Actually, before we even return to the y-intercept, we'll look at that second point and just see that it works. Right? If we start from this second point, and instead of going up and to the right, we go down and to the left. If we go down 1 unit, that brings us here to -1, and then we go left 3. 1, 2, 3, and it takes us back to that first point, that y-intercept that we started at. So if we repeat the process from there, we go down 1 unit, that brings us to -2 on the y-axis, and then we go 3 to the left. So that brings us to over here. And that's at the point -3, -2. So -3 in the x direction, -2 in the y direction. And so now these are the 3 points that we want to connect. So let's go ahead and connect those in as straight a line as we can. Oop, I'm already off to a bad start. Connect them in as straight of a line as we can. Something like that. I know my line's a little bit wiggly there, but let me see if I can straighten this out a little bit. Maybe just let me just give this another go. There's a 2. I'll just get rid of that. We know our y-intercept was over here at -1. And that's -1 right there. Yeah, let me give this another go. My line was terrible that first time. And our point was right here at -3. Alright, let's give that another go. And a point at 3. So if I start from there, we get something like this. Still a little bit wiggly, but I think I did a much better job this time, or at least I hope I did a better job this time. And hopefully that looks reasonably straight. So, great. Now we'll just label that quickly with its equation, 1/3 x minus 1. Okay, cool. Now our next step is to figure out what is the point of intersection of these two lines. So where do these two lines cross? And so the question that we're asking ourselves basically is, what are the x and y coordinates where these two lines cross? And the neat thing with what we're doing right now is you guys have actually seen the applications of this like concept before you've seen the sort of the graphical representation of it. So the applications of it would be the word problems that we did in the last unit, where you've got like I think it was on your test with Mr. Austin's red notebooks and blue notebooks, and how you could write those out with two equations with two variables and then solve for x and y. So what we're doing here is we're trying to figure out those x and y values, but we've drawn it out as a graph to sort of give us a rough idea. So if we look at our graph, we can see that the point of intersection is somewhere over here. Right? We don't know the exact value yet, and we're going to calculate it mathematically, but it should be negative, right? And if the point is right here, then you don't have to draw in those little dotted lines there. I don't know if you can see them, but well, we know it should be over here, so we know our x and y values should both be negative for sure, right? Our x values are negative in this direction, and our y values are negative in that direction. So since we're in the bottom left quadrant over here, both the x and y values should be negative. And if you draw in those little dotted lines towards the axes, then you should see that the y value, let me see if I can make that a little bit more obvious. The y value should be somewhere between -1 and -2, right? We've got this line, maybe it's halfway, we don't know for sure yet because of how unreliably I drew the graph. We don't know exactly if it's going to be like exactly -1.5, like exactly halfway between -1 and -2, or a little bit one way or a little bit the other way. But we have some confidence now that it should be negative, and it should be somewhere in the range of -1 or -2 or somewhere in between, right? And same deal with the x value. It should be negative, and it should be somewhere between -1, which is right here, and -2, which is over there. We've got something reasonably close to the middle. Maybe it's exactly halfway. We're going to calculate that mathematically to figure it out. So, to find the point of intersection, remember, well, the first thing we do is we equate those two equations. So basically, we take the stuff that's on the right-hand side of the equations, and we say they're equal to each other. And the reasoning for that is that in this first equation, we've got all of this stuff is equal to y, and in the second one, we've got this stuff, which, well, I mean, it's just an x, but, the stuff on the right-hand side is equal to y. Now, for your point of intersection, your y value is going to be the same, which means that this thing and this thing need to be equal at that point. So basically what we have is we've got 1/3 x minus 1 from equation 1 is equal to y, right? So far I haven't changed equation 1. I've just switched sides. I've put the y on the right side. We've still got y equals 1/3 x minus 1, which is the same thing that we had before. But we also know that y is equal to x, right? Like this. So basically, I didn't draw this out last time. The last lesson I recorded was at like 1 in the morning, and I didn't even think to do this. But basically what we have is right here is equation 1. And right here is equation 2, in case that helps you sort of understand how we marry those two equations together. So this is what we get. We combine the two equations like this, and we know that they're both equal to y. But if we've got, item A, if we've got like something A is equal to B is equal to C, then I know that A has to be equal to C, right? If all of these things are equal to each other, then I can just take out the middleman. I can just get rid of this B and say A is equal to C. So that's basically what we end up doing with these equations. is what I'm going to do next is I'm going to get rid of that y because it's causing us some problems right now, because we can't solve anything. And I'm just going to say that the right-hand side of equation 1, so this 1/3 x minus 1, is equal to the right-hand side of equation 2, which is x. All right, so hopefully that makes sense. Now our next step here is to actually get a value for x, and that's the goal now, is because if we can get a value for x, that'll be the x coordinate for our point of intersection. So that'll tell us this value right here for where exactly this point is in relation to the x-axis. So that's what it'll tell us if we can solve for this bit right here. So what I want is I want all the terms with x on one side and all the terms with numbers on the other side. I'm going to leave the -1 here. I'm going to take the 1/3 x over there, because when I take away 1/3 of something from the actual value, so when I take away 1/3 of x from x, I'm going to be left with a positive value. And I just like it to be that if I'm moving things around and I know I'm going to be subtracting, if I can keep the answer positive, I will keep the answer positive. So that's why I'm going to move the 1/3 x over. Also, the other way you could think about justifying it is if I bring that x over here over to the left side, then I have to also move the -1 over to that side. So I'd have to move more things if I did it that way. And I don't really feel like moving more things, so we're going to just take the 1/3 x over to the right side instead. So if we do that, that means we're left with just a -1 on the left, and then we've got x minus 1/3 of x on the right side. All right, simple enough. Now there's a couple ways you could think about solving that. I'll show you both. One is certainly easier than the other in this particular problem. So, well, actually, maybe there's three ways. One, the simplest way, once you're familiar with this kind of stuff, is just think about it. If I gave you 1 pie, and then I took away 1/3 of the pie, what do you have left? You should have 2/3 of the pie left, right? That's the easiest way to think about it, if you can reason your way to that answer. The other way you can think about it is if you draw out an actual, little pie, and you cut it into thirds, and then you remove one of those thirds, what do you have left? This part out here is equal to 2/3 of the pie, right? From over here to over here is going to be 2/3 of the pie. So you can draw a little picture if it'll help you out. The third way, the mathematical way to do it, would be, so you've got x minus 1/3 of x. Well, we've got a common factor of x. So if I pull out that common factor of x, then I'm going to be left inside a set of brackets. I'm going to basically have the exact same thing, but I've divided every term by what I pull out. So I've divided the entire expression by whatever I've pulled out in front, whatever they have in common. So here both these terms have an x in common, so I've pulled the x out in front. And then I'm going to rewrite the same equation, but I'm going to divide all of these terms, or both of these terms I should say, by x. So if I divide the first term by x, x divided by x is equal to 1. And 1/3 of x divided by x, again the x's just cancel, I'm left with 1/3, and the minus sign just comes along for the right. Now, here the mathematical way to do it, again you could reason your way to this 2/3 answer, but if you wanted to do it the mathematical way, then 1, if we wanted to get a common denominator, 1 is equal to 3/3, and then we subtract 1/3. 3/3 minus 1/3, that's just 3 minus 1 on top, and we keep the denominator the same, and we get an answer of 2/3. And so then, we can rewrite x and then 2/3 in the brackets, we can rewrite that as 2/3 x, like that. And so what we get is that -1 is equal to 2/3 times x. So 2/3 x, or 2x/3. All right, now we're not quite done yet because we haven't actually solved for x. So what we're going to do now is we're just 1 or 2 steps away from getting our actual answer. So what we have is 2/3 of x is equal to -1. But I don't want 2/3 of x, I want just x. So I'm going to divide both sides by the number that's sitting out in front. So basically what I'm going to do is I'm going to divide both sides by 2/3. So basically what I have is -1 divided by 2/3 is equal to 2/3 x divided by 2/3. Now if you remember when we're dividing fractions, we flip over the fraction and change the division sign to a multiplication sign. So we flip over that second fraction there. So what we're going to end up having is instead of 2/3, I'm going to have 3/2. I'm going to have a multiplication sign. And on this side, I'm going to have 2/3 x. Maybe I'll stick the x up here in the numerator now, just so that we're not confusing ourselves too much. So we've got 2x/3. That's a notation thing. If I have 2/3x like that, that's the same thing as writing it as 2x/3, like that. Okay, so those are both totally equivalent. This bit up here, sorry, I don't know if you could see that while I was writing it, but those two are totally equivalent ways of writing it. So what we have down here is we've got 2x/3, that's this bit, and then we flip over the fraction, so we get 3/2, and then we change the division sign to a multiplication sign. Now we chose what we're going to divide both sides by, specifically so that we get rid of this 2/3. And we can see that it does, because on the right side, these 2's cancel each other out, and these 3's cancel each other out. So we're left with just an x on the right-hand side, and then on the left side, we've got -1 times 3/2. Well, the 1 isn't going to change anything, so we're going to be left with the 3/2, but this minus sign comes along for the right, and we get -3/2 for x. So that's just our x coordinate of the point of intersection. Now we have to go and find the y coordinate. And let me rewrite the equations. I mean, they're both over on the graph and you have them on your page, but we know that equation 1 told us y is equal to 1/3 of x minus 1, and equation 2 told us that y is equal to x. On a test, on an assignment, whatever, you can use whichever equation you think is easier. You don't have to sub this answer back into equation 1. You don't have to sub it back into equation 2. You choose which one you want to sub it back into. You can choose the easier one. You can choose the harder one for practice. Doesn't matter to me. Some people will find certain things easier than others. If you've got an equation where you've got a slope but no y-intercept, so like the y-intercept is 0, your equation might be, y equals 2x. And in a different equation, you might have one where the slope is 1 and the y-intercept is something else. You might have y equals x plus 2. And some people will find one of those easier than the other, so you can sub it into whichever one you please. But in this one of these equations looks far simpler to use than the other. And for me, my money is certainly on equation 2 being the simpler one to use, because basically if I sub in the x value of -3/2, I don't have to sub in anything else. I don't have to do any calculations. It simply spits out that the y value is exactly equal to the x value. So as soon as I found the x value for this particular problem, the y value is going to be exactly the same. So this tells us that our x coordinate for our point of intersection is -3/2, which is the same thing as -1.5. So we were right that it was negative, and we were right that it was between -1 and -2, and we were right that it was exactly halfway, as it sort of looked over there. And the same thing down here, -3/2, that's the same thing, it's -1.5. So we've got the same thing, that the point of intersection for this graph is at an x-coordinate of -1.5, and the y-coordinate is also -1.5. And so what we've done is we started off with those two equations, we graphed both of them, we estimated where the point of intersection should be by looking at the graph, and then we calculated it mathematically, first by getting rid of y and solving for x, and then by subbing that x value back into the equations for y, and confirming that it is indeed the same answer for this particular problem, that the y value is the same as the x value. If you don't believe that the y value should be the same, try plugging -3/2 for x into the first equation, so this one right here, and let me know if you get the same answer or a different one. I subbed it into both of them, and I got -3/2 both ways, so I'm pretty confident in my answer. That being said, I planned out this lesson at like midnight a few nights ago, but I didn't get a chance to record it until just now. Before I let you guys go, I was going to do a second example today, but these points of intersection ones take a lot longer than I always think they will, so we'll do the second points of intersection example that I had planned for this lesson next time, and so maybe I'll get rid of that S in the title. Point of intersection example singular. Before I let you guys go, I want to give you a heads up. I should still be able to get videos out on time this week, or at least close enough to on time, hopefully, this week. If not, I will send math-related videos for you guys to check out during your class instead. So, maybe just like an interesting mathematical concept or something. Some of you may follow some YouTube channels like Numberphile or 3 Blue 1 Brown or something like that that have some interesting math videos. So I'll suggest something like that to your teachers on the off chance that I'm not able to get anything out in time. The reason that I might not be able to get anything out in time is that we have the coronavirus situation going on over here. So my university has actually closed. So I've got a couple days off, kind of, sort of. I still have a bunch of assignments due next week, which isn't the biggest problem. The biggest problem for me right now is that I have to move out from the university residence stuff. So basically my dorm, we're all getting kicked out of our dorms, basically. So I gotta get busy with packing and stuff. So on the off chance that I don't get anything out in time, I will send something to your teachers. It's just because this coronavirus situation is sort of complicating life at the moment. But other than that, I should be able to get things out on time. I'm going to try and record another lesson before your Wednesday class. But hopefully this all makes sense. Our next lesson will be the second points of intersection example, and we might go just a little bit faster with that one, just because now you've seen it a couple times. But yeah, as always, if you have any questions, let me know in a comment or by email, and if not, then I will see you all in the next video. Have a good one.